Okay, good day. This is Math 130. This is Introduction to Statistics. I am Professor McCulley, and this is Lesson 1, Introduction and Statistical Thinking. Let's get to it. So first off, hopefully we've had a class and you have been given access to these videos. My suggestion to you is that you also print off the video slides beforehand so that you don't have to take all of the notes and you can just add whatever clarification notes that you want. And so, however you're taking this course, I should have in the first class given you access to all of these notes. And again, I suggest that you print them off and follow along as best you can. This is a video, which is awesome because you can always press pause and you can always rewind. And then if you have questions, you are always welcome to leave a comment below. You can email me or we can talk about things in class. So let's move forward from there. So today we're going to talk about an overview of statistical thinking and how that's different from maybe some other algebra type classes that you've had before this. We're going to talk about some early definitions. And for me, one of the most important things especially when you're starting out in a statistics class, is that you really focus on your definitions and start to understand what the terms mean. Everything is based upon terms and definitions in statistics. And as we move forward, those terms build upon each other. So the new terms, the new definitions that we see as we move forward are usually based, at least in part, on things that we've had before. So if you don't know previous definitions or there are some holes in your previous definitions, you're going to struggle as we move forward. So whenever you see definition, make sure you take the time and make sure that you are getting those terms down and you understand what they mean. So let's get started here with a little bit of an introduction. What does it mean to have some statistical thinking? Statistics is different from most math courses as it asks you to make interpretations of calculations, not just find solutions. And so what that means is, like in algebra, usually you're solving an equation and you come up with a solution. The solution is x equals whatever. And sometimes those solutions have some units, like we can talk about solving for something going a certain speed in meters per second, or we can talk about an acceleration, or we can talk about or money or time or any other type of unit based solution. But in statistics, we're talking more often than not, about some sort of probability and being confident that a solution lies in a certain range. And statistics determines the likelihood of whether there's a difference between two outcomes. So we're going to say, is it outcome A or is it outcome B? And which outcome is more likely, and how confident we can be with that. So as we move on, let's kind of start talking about how we might think about with an example. And so I've got 5 situations here, and we're going to answer, excuse me, we're going to answer each of these 5 situations with 3 possible outcomes. We're going to say it's either impossible, possible but very unlikely, and we're going to say that it's possibly and likely. So our first outcome right here, this number 1, let me get my pen tool up here. Number 1, on the way to work yesterday, I arrived at 3 traffic lights and they were all red. Is that going to be impossible, possible but very unlikely, possible and likely? And I am going to say that to that the first answer is going to be possible and likely. And it seems to me like when I'm in a hurry, it's almost guaranteed that all of the traffic lights that I run into are going to be red. And the reason that we would say that is you only have 3 possible outcomes when you come to a traffic light, and it's any of those are just as likely as the other. And since there's only a small number of occurrences and a small number of outcomes, we could say that with fairly good confidence that that's going to be possible and likely. Number 2 says everyone in a given classroom has the same birth date. Well, it's a little bit different than the first one. I mean, we could say it's possible, But because birth dates, there's only 3 outcomes when you're talking about traffic lights. But when you're talking about birth dates, we're talking about 365 different outcomes for that. And if you have a classroom full of kids, instead of 3 instances of those traffic lights, you could have 20, 30 people in there. So since the number of outcomes is so much higher and the number of occurrences is so much higher, we're going to say that that's possible, but it's going to be unlikely. The third one, Mother's Day will be on a Monday next year. Well, we're going to say that one's going to be impossible. Simply because Mother's Day is defined to be on a Sunday. Yeah, can't spell. Sorry. That's why they pay me to teach math and not spelling. Number 4, Thanksgiving will fall on a Thursday next year. We are going to say that that is possible and very likely, since Thanksgiving is defined to be on a Thursday. And finally, we're going to say, I bought a new car last week and I found a $100 bill in the truck. That is possible, but I would say it is very unlikely that you find a $100 bill in the truck of a brand new car. Moving on, statistical significance versus practical significance. Statistical significance means that we can prove that an outcome is either statistically likely, statistically unlikely, or unable to distinguish it from chance. Practical significance implies that the result is useful, and that's practical significance is really in something that is a realm of common sense. Does it really make sense? And our first example here really kind of clarifies the difference between those two things. And so our first example says a study of a weight loss program using a particular method was performed. Either the method works or it does not. Those are our two possible outcomes. Study results, 40 subjects that used the method lost an average of 3.3 pounds over a 12-month period. Statistical analysis can be used to show that if the method does not work, then there is only a 3% chance that these 40 people would lose an average of 3.3 pounds. Well, 3% chance that these 40s will lose an average, if that's only a 3% chance, well, statistically, that's significant. So these results, yes, and we're going to see that 5.5% is usually our boundary, and this depends on the situation, but anything below 5% is usually a good outcome for us. And so we're going to say, yes, this has statistical significance, but does it have practical significance? Well, if you only lost 3.5 pounds over 12 months, it took you 12 months to lose 3.5 pounds, are you going to use this method? I'm going to say no. And just me personally, if I had to go 12 months before I lost 3.5 pounds, I'd probably quit after the first month. I'm going to expect to see, or expect to need more of a result of weight loss much earlier in a system for me to stick with it. So in this particular instance, is it statistically significant? Yes, that 3% chance that 40 people would lose an average of 3.3 pounds, that's significant. But is it practical? No, because the weight loss isn't very good. Let's talk about another example. A study compared surgery with splinting for subjects with carpal tunnel syndrome. The surgery either better than using splints, or there's no difference between the surgery and splints for treating carpal tunnel syndrome. Study results that among 73 patients treated with a surgery, there was a 92% rate, or 92% success rate. Among 83 patients treated with splints, there was a 72% success rate. Statistical analysis can be used to show that if there is really not a difference between the surgery and splinting, then there's about a 1 out of 1,000 chance of getting these study results. And so again, do these results have statistical significance? Yes, they do. 1 out of 1,000, well, that's only 0.1%. Yeah, 0.1%. That seems pretty good that there's a difference between getting a surgery or getting a splint. Do they have practical YED? Oh my goodness. Sorry. YES. There we go. Do these results have practical significance? Of course they have practical significance. 72% success rate, 92% rate. That's important. That's certainly something that you're going to want to try. But what are you going to do? Are you going to have the surgery or are you going to have a splint? Well, that's going to really depend on the person who's getting the procedure. Do you want to go under the knife right away? Is that something that you as a person or as a person who has the opportunity to make a decision want to do? I would say that a 72% success rate is a pretty good rate. And so, me personally, I might try to have the splint, and that way I don't have to have my wrist cut open. I might try that splint first, and since the success rate is so good, I might try that first. And then if that doesn't work, then we might move on to the surgery, because I would, and again, not being a medical professional, I would assume that the surgery is going to cost more than getting a splint. And so I would try that splint first. That might not be you, but again, that's what it means for practical significance. That you're kind of using your common sense. All right, moving on to some definitions here. First definitions, data is information coming from observations, counts, measurements, or responses. Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. The population is a collection of all outcomes, responses, measurements, or counts that are of interest, and a sample is a subset or part of a population. These are terms that we're going to use quite a bit as we move forward. Continuing on with some more definitions of parameter. Parameter is a numerical description of a population characteristic. A statistic is a numerical description of a sample characteristic. Descriptive statistics is a branch of statistics that involves the organization and summation and display of data. Inferential statistics is a branch of statistics that involves using a sample to draw conclusions about a population. A basic tool in the study of inferential statistics is probability. So let's have some examples about these definitions here. In a recent survey of 614 small business owners in the United States, they were asked if they thought social media presence was valuable. 258 of the 614 respondents said yes. Let's identify the population, and let's identify the sample, and let's describe the sample set. And so the population is the responses of all small business owners. If we were to identify the sample consists of the responses of the 614 small business owners in the survey. And the sample data set consists of the 258 owners who said yes and the 356 owners who said no. All right, moving on. Example, which of the following represents a parameter and which of these represent a statistic? Last year, 90% of students in Mr. McCully's class showed a year's growth on their STAR math test. Well, and then the second one is a random sample of 400 Coshocton County students showed 67% showed a year's growth on their STAR math test. Well, if we're talking about this first one, this one refers to a parameter where the population is all of Mr. McCully's students. And this bottom one is a statistic. And it is a portion of the population of Coshocton County students. All right, one more example here. A study of 800 10th grade students who took the AP test, AP Calculus. They didn't take the AP Calculus test, they just took the class, and did not take AP Calculus class. For the students who took AP Calculus, 90 or 89% graduated college. Of the students who did not take AP Calculus, 58% graduated college. What part of the study represents descriptive statistics? Well, the descriptive statistics, let's see if I can do that again. What part of the study represents descriptive statistics? Well, the descriptive statistics are the 89% that graduated college and the 58% that did not graduate. Or the 58, actually, they did graduate. Sorry about that. And the difference is these guys took calculus and these guys did not take AP Calc. All right, so what conclusions might be made using inferential statistics? Well, what we might, and I want to really underline this might, we might be able to include that if a student took AP Calc in high school, they were more likely to graduate college. All right, but we would need to use, and I gotta put a note here, much more work would be needed before we can make this conclusion. All right, well, that's all I got for lesson one. So, did a lot of work. Let's do something fun here to finish her off. So today, I might have said this in class, but I am certainly the king of the geeks, and one of my favorite things are Marvel movies. So we're going to finish off this lesson with a Marvel fun fact of the day. The Marvel Cinematic Universe is very well planned out and connected, as you can see in this picture, and I'm pointing to it right here, that in Iron Man 2, which was released in 2010, there is a reference to Wakanda, Black Panther's home country, being foreshadowed, even though it would be another 8 years before the movie Black Panther would be released and before we would see the Black Panther in, what was that movie that we saw it in? Civil War was the first occurrence of Black Panther. Well, that's all I got for today, folks. Have a good one. I'll see you back in class. Goodbye.